Good morning. So today we are going to see about half subtractor circuit. Okay. So first we see this definition. Half subtractor is a combinational digital circuit that subtracts a single bit from another bit and gives difference and borrow. So we have two inputs A and B. These two are inputs and we have two outputs and they are difference and borrow. So the difference is denoted here as D and the borrow will be denoted as B. Okay. Since it is single bit subtraction, we'll be naming it as half subtractor. Okay. So the steps to be followed, it will be have 4 steps. The first one is block diagram. Second one is truth table. Third one is Boolean expression. The fourth one is the final step is the logic diagram. Okay. So we move on to this block diagram. So this is the block diagram. Here you have the two inputs, namely A and B, and we have the two outputs, namely difference and borrow. So in order to differentiate this B with this borrow output, we name this as B naught. Okay, so B naught is output and this B is the input. Okay, then we go for this second step. It is framing the truth table. Okay, so A and B are the inputs as we know. So it is 0 and 0. We are going to have only a single bit and we can form 4 combinations, right? 0 0 or 0 1, or you can have 1 0 or 1 1. 4 combinations are possible. But the thing is, it is the subtraction. Okay, subtraction in the sense we should find the difference between these two. So what's the difference between 0 and 0? No difference, right? So it is 0. So we write this as D, difference is 0. What is the difference between these two? The difference is 1, isn't it? There is a difference of 1. And if you go between these two, then also the difference is 1. And when you go between these two, that is this 1 and 1, what is the difference? The difference is 0. So in this way, we form this output D. Okay, 0 0 0 0 1 1 1 0 1 1 1 0. So we got this D output. Now how to get this borrow output? Okay, so the borrow is the one when you get the borrow from the previous, from the, that is previous okay, for example here it is 0 minus 0. There is no need for getting borrow for the subtraction, so borrow is 0. So when you want to subtract a 1, okay, so we want to subtract a 1. This one is to be subtracted from the 0. Since the 0 is less than 1, you cannot subtract. At that time, you need to get a borrow, right? So a borrow should be got. Okay. So this is how we obtain this B naught output for this. Similarly, when you go for this, when you subtract from this, okay, when you subtract a 0 from this one, no need to get a borrow. So borrow is 0 here. So similarly for subtracting this one from this one, no need of getting a borrow. So borrow is 0. So for this particular case alone, you need to get a borrow because this 0 is less than this 1. So you cannot make a subtraction directly. So you go for this borrow. So now you compare this table. 0 minus 0, there is no difference and no borrow is needed. 0 minus 1, the difference is 1. And you need to get a borrow for this. 1 minus 0, the difference is 1, but no need for borrow. And this 1 minus 1, the difference is 0 and the borrow is 0. This is how we obtain this truth table. Okay, so we got the truth table. So once you get the truth table, what is your next step? You know that the next step is writing the Boolean expression. Okay, so the Boolean expression has to be written. For this, we'll go for the previous step. So from the truth table only, we need to write the Boolean expression, right? So for this, we have actually two outputs, D and B naught. Then if you have two outputs, for that outputs only you have to write the Boolean expression. Okay. So it is D. So consider this column alone. Okay. This column alone, D column, which is the D output. In that, how many ones you have? Here you have one, another one. So either for this combination, you will get the output as 1, or for this combination, you will get the output as 1. So we have to write the expression for these two. Okay. So for this one, what is the input combination? Here, the input combination here, A is 0. So we know that A is 0, and at that same time, this B is 1, isn't it? And so we put it, B is 1. Or for this combination, we will get a 1 for this D, right? So what is this input combination? Or, okay, what it is A is 1 at that time and B is 0. We already know how to write for this. So for this first one, A is 0 means that represents A bar, B is 1 means that represents B, and this dot operator, it is nothing but dot. Okay, and operators dot. Similarly, for this A equal to 1, it is A literal as such, and for this ampersand or and operator, it is dot, and B equal to 0, it is B bar. Okay, so what do you get for this? It is A bar B, then plus sign. Okay, because of this R, you have to put a plus. Then for this combination, it is A B bar. Okay, so now I write it. It is A bar B plus A B bar. So if you compare this expression along with this half adder, both will be the same. In the half adder circuit, it is sum. Sum is equal to A bar B plus A B bar. Similarly, for difference also we get the same expression. Okay. Then we go for the next. What is the next? Next output is B naught here. So for the B naught, you go for this column. In this we have only one. A single one is available at the output. For that, the input combination is this one. So A is 0. That means A bar, and okay, so and means dot product, and this B is 1. So you have to write the literal as such. So what is the answer for this? This A bar B. This is what being represented in the next slide. So Boolean expression is A bar B plus A B bar. And this B naught output is borrow output is A bar B. You also know from the previous video that A bar B plus A B bar is nothing but A exclusive or B. XOR gate. Okay, we can use the XOR gate also. Now we go for the next. The next step is drawing the logic diagram. So you know that drawing the logic diagram means how to draw. The expressions, the Boolean expressions are important. D is equal to A bar B plus A B bar, right? Okay, so how we'll draw? We have two inputs A and B and one output. Okay, right. And the second output is B naught, that is A bar B, isn't it? That's what we obtained. This one. So for this, how to write this Boolean, from the Boolean, how to draw the logic diagram? So you draw two lines from here. After that, you go for this first term. So this first term is A bar B. The second term is A B bar. So they are combined using this plus operator, isn't it? So we go for the first term. So what it is? A bar B. So A bar B means this is A bar. Okay. B is, this is B. Both are combined using this AND gate. And the second term is AB bar. So we'll take the connection from this A, and the second connection is B bar. So inverted and then given. So what is this? This is B, this is A, this is B bar, and this AB bar is combined using AND gate. Then both are combined using this plus is OR, right? So this is your OR gate. So this is your output D, first output. Then the second output we need is bar output, that is A bar B. So you take it from this A bar, this is A bar, and this is B. So they are combined, and then you will be getting this, which is your B naught. Another thing also you can do, instead of drawing this, you can also take okay. So this also represents the same thing, right? A bar B, this is AB bar. So you can also take the connection from here and then you can represent it as B naught. This is also valid. Okay. So this is how you can draw the logic diagram for half subtractor. Okay. But this is using basic gates. Only we are using basic gates here. So how many gates here? We used 1, 2, 3. Okay, this is 1, 2, 3. Then your 4 and 5. We need a 5 number of gates. But if you use XOR gate, then we'll be having only 2 number of gates, because this expression is nothing but A exclusive or B. So that I can draw this logic diagram like this is AB, and then you draw this XOR gate. This is your D. Then you take this, okay, A bar B. So we need to have 3 gates here, A bar B. Yes, this is B naught. So this is using XOR, logic diagram using XOR. So it is being drawn in the next slide, like this is using basic gates. So this is A bar B, so we go for A bar B. Here you obtain this, and the second term is A B bar. You get this, so you get this D. Similarly for this B naught, you go for this A bar B, right? Okay, so you get this using basic gates. This is what I have done already. And using XOR gate also, you can draw like this. So here you can do it with the help of three gates. And in the previous one, using basic gates, 1, 2, 3, 4, 5, 6, 7, I have here taken. But if you take the connection from here just, and then you can neglect these two, there is no need to draw this, then only you'll be having 5 number of gates. That's also possible. Okay, same circuit only, right? Now it is being given in a single shot. So we'll summarize. So this is the block diagram. Inputs A and B, outputs D and borrow output, the truth table. So combining this inputs combinations along with the output possibilities, these are written, and the Boolean expression D is A bar B plus AB bar, which can also be written as A exclusive or B. Okay, so this is A exclusive or B using XOR gate. And this B naught is A bar B. So the last step is logic diagram. Using basic gates it is drawn. Similarly using XOR gate it is drawn. Okay, thank you.